Today we're going to talk about the basic trig identities. You saw these in Algebra 2 trig before, but just the basic identities and how to use them. We have this sheet here, trigonometric identities, and you'll either get it in person or it is available on Canvas, where we're going to end up populating all of these places throughout the unit. Today we're going to focus on these three: the reciprocal identities, the ratio identities, and the Pythagorean identities. First up are the reciprocal identities. There's technically 6 of these, but the 3 I'm going to focus on is cosecant, secant, and cotangent. Okay, we've talked about these before. This is nothing new, but these 3 are the reciprocals of our big 3: sine, cosine, and tangent. So cosecant is 1 over sine of theta, secant is 1 over cosine of theta, and cotangent is 1 over tangent of theta. The ratio identities, or the quotient identities, are tangent and cotangent and their relationship with sine and cosine. So tangent is equal to sine of theta over cosine of theta. Cotangent is going to be cosine of theta over sine of theta. Next we have the Pythagorean identities. And I'll go ahead and derive these for you, and then we'll return to this sheet here and put them here. Okay, so we want to consider the unit circle. So on the unit circle, we have all of our different values. Our hypotenuse is always 1, and then we have these coordinates x and y, which refer to the sides of the triangle here, x and y. So we know just from the Pythagorean theorem that x squared plus y squared equals 1 squared. Well, this x on the unit circle is also equivalent to the sine of this angle here. So x can be replaced with sine of theta. No, cosine of theta, sorry. Y is going to get replaced with sine of theta. And then we end up rewriting this as sine squared theta plus cosine squared theta is equal to 1. If you have this 2 here, or any value except for -1, that's just going to be that whole trig function raised to that value. So we're going to add to this list sine squared theta plus cosine squared theta is equal to 1. I'm also going to put 2 variations here just because we commonly use them. And that's taking this and solving for sine and solving for cosine. So sine squared theta is equal to 1 minus cosine squared theta. And cosine squared theta is equal to 1 minus sine squared theta. There are 2 other variations that start with this one, but involve other trig functions. So I'm going to go ahead and derive those for you. So we start with our main identity here, sine squared theta plus cosine squared theta equals 1. And I'm going to divide everything by sine squared theta. When I do that, sine squared divided by sine squared is just going to be 1. Cosine squared divided by sine squared, well, cosine over sine is cotangent, so cosine squared over sine squared is cotangent squared. And then 1 over sine squared is cosecant squared theta. So that's our second one. We'll also do the same thing with cosine. If I take these all and divide by cosine now, sine divided by cosine is tangent, so sine squared over cosine squared is tangent squared. cosine divided by cosine is going to be 1. And 1 over cosine is going to be secant. So we add those to our list. So 1 plus cotangent squared equals cosecant squared, and tangent squared plus 1 equals secant squared. So now we're going to use these different identities in different situations. So this is the first section in chapter 5. So 5.1, trigonometric identities. All right, so our first example. If cotangent of theta equals 2 and cosine of theta is less than 0, find sine of theta and cosine of theta. So I tend to always go back to, when in doubt, right triangle trig. So we know that cotangent, okay, using right triangle trig, if tangent is opposite over adjacent, cotangent is going to be adjacent over opposite. So we're going to make a triangle here with that information. So I'm going to say, here's my mystery angle theta. We don't know what it is, but we don't need to. But we know if cotangent is 2, we'll treat that as a 2 over 1. That means the adjacent side is going to be 2, and the opposite side is going to be 1. Again, using right triangle trig, if I want to find sine or cosine, I need the hypotenuse. So we'll do the Pythagorean theorem, where 1 squared plus 2 squared equals this squared, which is going to make this the square root of 5. So from there, sine of theta, cosine of theta. So sine of theta is going to be the opposite over the adjacent. So that's going to be 1 over root 5. Now, before I move on, and I will rationalize this, there's this other piece of information here. Cosine is less than 0. We're going to use that to determine whether our functions are positive or negative based on the quadrant. So what I have here is tangent and cotangent are positive, and cosine is negative. Well, that's going to occur when the x value is negative, so it's either going to be here or here. Cotangent is going to be positive in this quadrant. So here, cosine is negative, cotangent and tangent are positive. Well, in this quadrant, tangent is also negative because our x and y values are negative. So this is going to be a negative root 5 over 5. Now, I'm not going to be too picky on rationalizing because these are the same thing. It's just this is just more commonly seen in the math world. Cosine then is going to be the adjacent over the hypotenuse. It is also negative, so negative 2 over root 5, or if we rationalize it, negative 2 root 5 over 5. All right, so now we're going to simplify, and we're going to use different identities in order to do that. A lot of this chapter is going to be just manipulating trig functions for different purposes. So what we're going to do here is just kind of practice those things. So first thing I see here, 1 minus sine squared, and we added this to the identity list. Since cosine squared plus sine squared is equal to 1, then 1 minus cosine is sine and 1 minus sine squared is cosine squared. So in this case, I can replace this with cosine squared. So we'll copy this part down, and then we're going to multiply this by cosine squared. Well, if I have cosine squared times 1 over cosine, that's really just dividing. So this is just going to be cosine of theta. Next one, cosine of x, tangent of x minus sine of x, cosine squared. We've been using theta, but there can really be any variable here. Theta is very common, x is very common, and you'll also see other things, alphas and betas and any other letters. One big thing that we're going to be doing over and over and over in this chapter is taking any trig function and substituting it in terms of sine and cosine. So in this case, the only thing that's not a sine or a cosine is this tangent. So I'm going to rewrite that as sine of x over cosine of x. Okay, well here, if we have cosine times sine over cosine, those eliminate. So I have sine of x minus sine of x cosine of x. We're going to be doing a lot of algebra stuff in these problems. So the algebra step we're going to do here is I'm actually going to factor a sine out of both of these terms. So if I factor a sine out here, I'm left with 1. If I factor a sine out here, we get a cosine squared. Well, that's just sine squared. And then sine of x times sine squared is going to be sine cubed x. All right, this next one's going to take a little bit more effort here. But again, it's just going to be using identities and algebra. The first thing I'm going to do is replace all of these secants with 1 over cosines. Okay, in the denominators here, I'm going to get a common denominator. So I'm going to turn these 1s into cosine over cosines. So this is going to be cosine of x over cosine of x. And same thing over here. Okay, that allows me to combine them. So keep the numerators coming along here. Our new denominator now is going to be cosine of x minus 1 over cosine of x. This is going to be cosine. This is 1 over cosine. 1 over cosine. So then in the denominator we have cosine of x plus 1 over cosine of x. Now before I move on, I want to do a numerical example of where we have some fraction over some fraction and the denominators are the same. So let's say I had something like 3 over 5 over 4 over 5. Well, I can rewrite that as 3 over 5 times 5 over 4. Well, the 5's are going to cancel, and you're just going to be left with 3 over 4. So anytime we have something like this where the denominators are the same, we can just take the numerators, and that's going to be what our fraction reduces to. So that's what we have over here in both of these. So I can take these and just get rid of the cosine denominators. So this is now going to be 1 over cosine x minus 1. This one's going to be 1 over cosine of x plus 1. All right, now we're going to do common denominator again. So I'm going to multiply this one by cosine of x plus 1 over cosine of x plus 1. And I'm going to multiply this one by cosine of x minus 1 over cosine of x minus 1. All right. So this is now going to be cosine of x plus 1 over, if we FOIL this out, we're going to have cosine squared minus cosine plus cosine, so those middle terms will go away, minus 1 minus cosine of x minus 1 over that same denominator. Okay, well, if I combine these, cosine minus cosine is going to be 0. So we're going to have a 1 minus a negative 1. So that's going to be 2. And then in the denominator, if we have 1 minus cosine squared, that's sine squared. Well, if we have cosine squared minus 1, that's going to be a negative sine squared. So we can rewrite this whole thing as a negative 2 cosecant squared x. Or you can leave it like this, the first part here. next example, pretty much similar, but how we're being asked is a little bit different. So rewrite as an expression that does not involve a fraction. So we have a fraction, 1 plus tangent squared x over cosecant equals, well, we'll figure that out. Again, turning everything in terms of sine and cosine. Okay, so I'm going to replace the 1's going to stay. Tangent is going to become sine squared over cosine squared, all over 1 over sine squared x. I'm going to get a common denominator up here. So this 1 is going to become, I'm just going to go ahead and replace it here, cosine squared over cosine squared. So when I add those, we get a cosine squared x plus sine squared x over cosine squared x all over this. So I'm going to do two things in this next step. Cosine squared plus sine squared is just 1. So we're going to have 1 over cosine squared. And then rather than dividing by 1 over sine, I'm going to multiply by sine squared x over 1. Well, sine squared over cosine squared is tangent squared. So this is just a brief introduction to using trig identities. We're going to be using these skills in a number of different ways over the next coming weeks.